the other question that invariably comes up when it's talking about it is paralleling generators, yeah, for AC. Never a problem with DC, you can just knock the thing in. But what we must do is, when we're paralleling generators, is make sure that the running machine, whatever its frequency it is, the incoming machine, so the running machine and the incoming machine, must be spot on in terms of the frequency and the voltage. Okay, so even when it's necessary, two generators, vitally important that you follow this procedure. And it's a question that comes up quite a lot of the time. Okay, so the running machine, let's say, for example, it's got a capacity of 1,000 kilowatts. And we know we're going to go into port, we need to use bow thrusters, whatever it is. We know that our load is probably going to be around 1,500 kilowatts. So therefore, we make the decision, yes, we need backup. We can't get 1,500 kilowatts out of one machine, but we could get 750 out of two, yeah, which will meet the loads that we want. So we need to start our second machine. So do your pre-start checks and start the incoming machine. The AVR, yeah, when you look at the panel, yeah, the AVR should control the voltage to give you your required voltage. If it doesn't, then you either got a problem with the AVR, or go back a step, you've got a problem with the excitation system. But normally, yeah, as soon as we say it, you'll see the voltage. When it comes up to speed, yeah, we've got the required voltage. So we need to match both the voltage and the frequency. The incoming's got to match the frequency and the voltage of the running machine. The incomer must be synchronized. So the incomer speed is controlled by the main engine governor and should be adjusted to give the same busbar frequency, which is 60 or 50 hertz, whatever it is. So we can play it. So the incomer voltage is, as I said, generally set by the AVR. Normally they work quite well. We then turn on our synchroscope, okay, and adjust the speed of the incomer such that it matches the speed or the frequency of the system. There are several types, but if we just look at the old type with just a pointer, yeah, what we want to do is get this pointer rotating around the indicator, yeah, round about, it does one full rotation about every 4 seconds or so. Okay, so it goes round 4 seconds. So if it's going too fast, you need to slow it down. If it was going the other way, anti-clockwise, then we need to speed it up. So we adjust the speed until it goes round, coming around, takes about 4 seconds to go from 12 o'clock to 12 o'clock. And when the pointer gets to around about 11 o'clock, press the button. Yeah, put the breaker, close the breaker. I realise most vessels have power management systems and automatic, but the surveyor, it's all broken as far as he's concerned. He wanted you to do it manually. Okay, so then you put the breaker in, and then what we need to do is share the loads between. So we've got our 1,500 kilowatt load, for example. Yeah, we then need to share the load, so we speed one up and slow one down until we get 750 kilowatts on both machines, which gives us the load. The AVR is a controller. Okay, so there's a little bit of, now you may not be familiar with control systems in jet, but it is a controller. And the AVR just senses or takes the value of the line voltage, which in this case we wanted 440. And it takes that through to something called a comparator, which is inside the AVR itself. Yeah. And it compares what the actual line voltage is against the line voltage that we want. Okay. So, which is set at desired voltage. Okay. So it then sends this signal, it's all done electronically, to an amplifier, which amplifies the signal. Yeah. Which then sends a signal down to an SCR as a silicon controlled. It's basically a thyristor. It's called a gated thyristor. Yeah, and this is like a valve which allows the flux, the current, the DC current that comes from the excitation system. It controls the amount of flux that goes into the rotor of the alternator or generator. Okay, so that it goes through this gated thyristor, which controls the flow of DC, must be DC, current through to the excitation circuit in the generator rotor. Thus, you will either increase or decrease the voltage. That's how the AVR works.